Hi. In this short video, we're going to talk about how to graph y equals the greatest integer of sine of x. What we have here is a composition of two functions. We've got sine of x inside the greatest integer function. So hopefully you understand the concept of composition, and if you don't, please go back in your book and review that idea because it's important. It's going to come up a lot. It's going to come up when we talk about the chain rule. It's going to come up when you do UDU substitution. Composition is pretty much everywhere in the calculus, and you can't avoid it. So might as well get right with it. So this is the point of this video, is to talk a little bit about this particular problem that seems to have tripped up a few students and caused some questions. And so I'd like to put this video out there so that you can get some experience in thinking about how this works and hopefully do it for yourself. Okay, so graphed here you can see is the greatest integer function. The greatest integer function is the largest integer that's less than. So for instance, the greatest integer of 7 halves, we know 7 halves is 3 and a half. The greatest integer would be the biggest integer that's smaller. So the biggest integer that's smaller would be 3. Because 3 times 2 is 6, plus 1 is 7. Okay, so that's how this works, and here's a graph of this function right here. So for instance, if we're talking about an x value anywhere between two, or first, the easiest place to start, let's start with the integers themselves. So what is the largest integer that's no bigger than 0? Well, it's 0 itself, and that's true for every other integer. So the greatest integer function at the integers is actually equal to the integer values. Okay, that's what you see here with the red dots at minus 2, minus 2, minus 1, minus 1, 0, 0, 1, 1, 2, 2, etc. So the greatest integer function is equal to an integer at every integer. And in between the integer, it's also equal to an integer, but it's equal to the smaller, like we illustrated here with the 7 halves. Okay, so between 0 and 1, it hasn't reached 1 yet, so the biggest integer that's no bigger is still 0. So the function here between 0 and 1 is 0. At an integer, it jumps. Okay, so as we approach 1, at 1, the value jumps up to 1. And then for values between 0 and 1 here, the function again is constant. Its value is the greatest integer that's less than. So between 1 and 2, the greatest integer is 1. So the function values are here. Okay. Now, my plan, your plan, possibly when you're attacking a problem like this, so let's think about composition for a second. So what's the input to the composition? The input to the composition is the input to the function sine of x. So the domain of our function y will be the domain that's being put into sine of x. So we could think about that naturally in terms of pi's. 0 to pi over 2, pi over 2 to 3 pi over 2, whatever. The domain is all real numbers, but it's convenient for us to think in terms of pi's because that's what's convenient for the sine function. Now, the second thing to notice is that the output of the sine function becomes the input to the greatest integer function. And that's the only trick to this entire problem, is juggling that relationship, is looking at the y-axis on the sine graph as the input to the greatest integer function that we have drawn here. Okay, so what we're going to do through the magic of television is we are going to miniaturize this part, and we're going to blow this part up. We're going to make this part really tiny and put it away. And now we're going to draw on the we're going to draw our graph right here on top of this graph, and you could do this and then transfer it, but this will give you the basic idea. So the first thing is, what we're interested in here, well, we're interested in both the domain and the range. Okay, so notice that here, oops, notice that here, it's pi over 2, pi, 3 pi over 2, and so on. So our function at 0 is 0, and the greatest integer of 0 is 0. So the first thing you could do if you wanted is you could just walk through this graph and find every place on the graph where the graph is an integer, and we know that the greatest integer function is going to keep that the same, right? Because the greatest integer of an integer is an integer. So that those pieces are going to stay the same. So for instance, we could put nice circles, nice dark circles, wherever we've got integer values, because we know that at those values the greatest integer function of sine of x will remain unchanged. And that's not a bad way to work. You make that observation, you go through and you do that. That gives you kind of like you like to do. You like to make those little things with the x's and y's, and you plot your points and then you connect them up. So there you go. That's a nice easy thing to do. So you can, but it's an important observation that the greatest integer of an integer is an integer, and it's the same integer. Okay, now what about between 0 and pi over 2? Between 0 and pi over 2, you see that the function takes on values here, between 0 and 1. And what does the greatest integer do to anything between 0 and 1? It makes it 0. Okay? So that means that the greatest integer function is going to be 0 between 0 and pi over 2. Okay? At pi over 2, it's going to jump up to 1, so we need to make an open circle here. Okay, and that's not easy to do with my fat pen here. But you see that here, the function is 0 until it gets to pi over 2, then it jumps up to 1. Now what about on the other side? On the other side it comes back down. So these y values here of the sine function are between 0 and 1. So that means that the greatest integer of those is going to be 0. Okay? Now, I think you get the idea. What you're looking at is the range. You look at the range of the y values. So here, what are we looking at in terms of the sine function? We're looking at its range. So we're looking at these values now, okay? We're looking at these values. And what does the function do? Okay? The function here is between 0 and minus 1, and the greatest integer, therefore, is minus 1, because that's the largest integer that's less than. Okay? So that means that on this interval, okay, here, we have to draw an open circle. Again, kind of a problem for my fat pen. Okay, so that's what this graph looks like. So between 0 and pi, my graph is essentially 0, except at pi over 2 where it jumps up to 1. Now on this part, again, look what happens. On the other side here, we're in the same situation. Okay, so all the way up until we get to 3 pi over 2, where we have to put another open circle, our graph is minus 1. Okay? And then at 3 pi over 2 it jumps. Now what happens again? Now we look at the next piece. The next piece of our graph lives here. Okay? So what does that mean? That means that our graph is 0 until it reaches 2 pi, and then it jumps up to 1. Okay? And now you should be able to do this without any problem, because here, what are the function values? Okay, we need an open circle here. This is minus 1. What's going to happen over here? This is an open circle. This is minus 1. And I think you see what's happening here. You have an open circle here. We got 0. Okay? So this right here is a graph of what we were interested in. If you are unsure about this, you can do two things. You can think about this function. Try to graph this function yourself. Okay? Try to graph y equals the greatest integer of cosine of x. Okay? That's one thing you can do. Or instead of graphing the greatest integer, you can graph the least integer that's larger. Okay, that function is called the ceiling. Okay, usually these functions are called the floor and ceiling. This one here is usually called the floor. Okay, because it's the smallest integer. Notice how you're always going backwards to the smallest integer, going to the left. And this one here is called the ceiling. And the ceiling goes forward. And the graph of the ceiling that should be something that you should try. So if you haven't already tried to graph the ceiling function, okay, then this is something that you could try, and this is a second thing you can try to prepare yourself for potential test type questions, or just to test your understanding, more importantly. Okay, thanks for listening. Bye bye.